you will be learning more, like I said, later down the road. All right, now we said at the beginning that we want to use this method to graph things. So let's jump into using that idea. In this gray box are some key important rules. If you follow these rules, then you're going to get it perfect. Just like PEMDAS, you have to follow order of operations if you want to get the right answer. Same with graphing. You have to follow these 4 simple steps, and you'll do them so many times you won't even have to reference it. But they're right here for you if you ever need it. So first thing, steps to graphing an equation in slope-intercept form. Make sure your equation is in slope-intercept form. We're good there. All right, step 1, determine the slope and y-intercept. So my slope, my y-intercept. The slope is the number right in front of the variable x. I was going to write x. Right in front of the variable x, so it's negative 2/3. And my y-intercept is a number all out by itself. Okay? Step 1, good. Plot the y-intercept first and put a point there. So my y-intercept is 4, so I go 1, 2, 3, 4 on the y-axis and put a point. Step 2. From that point, continue to plot the slope, which is rise over run. Put your second point where you end up. So my slope, like we know, is rise over run. So it needs to be a fraction, as we have here. So really, my rise is negative 2, my run is 3. I can put that negative either with the numerator or denominator. I'm, just for consistency, going to put it with the numerator, okay? But, so now from this point, from that point, it says plot your slope, rise over run. So my rise, from this point, I have to do the rise first, which is a negative 2. So that means I'm going to go down because it's negative 1, 2. Then I do my run, which is positive 3, 1, 2, 3. Put my second point. Put your second point where you end up. That's step 3. In step 4, draw a line through the 2 points, connect them. So let's do that. A little unstraight on my end, but perfect. There's your graph. And if you wanted to check it, you could use the intercept method or you could use a t-chart. All right, let's try example B. I'm going to go ahead and I'm going to change this to y equals 5x minus 2 just because that's going to go off the graph because our y-intercept's too big. All right, so it is in slope-intercept forms. That's our pre-check. My slope is 5. My y-intercept is negative 2. Don't forget that negative. All right, now before I go anywhere, up above we had our slope as a fraction. Here it's not, so we need to turn it into a fraction. And to do that, we can just put that simply over 1. 5 over 1. All right, let's go ahead and start plotting. First thing is your y-intercept. Notice the b value goes first. It's like alphabetical, b and then m. So first thing I do is plot negative 2 on the y-axis. That's my y-intercept. That's where the graph has to cross it, so that's why I have to plot it first. Then my rise, I do my slope. Rise 5, 1, 2, 3, 4, 5, and then my run 1. Okay, so I go to connect. Whoa. Again, it's a little trickier on here. Straight line, hopefully, and that's your slope. So we found m and b. We plot our y-intercept first. We go up our slope. Our rise was 5, and our run was 1. Connect. Okay, let's take a look at some more. Now letter C, again, you should notice this is not in slope-intercept form, so we need to get it in slope-intercept form. To do that, I'm going to subtract 3x. What we've been calling this so far is function form. All right, now these weren't like terms, so that's why they are the way they are. I'm going to divide every term by 5 because I have to be fair to everything. Just like if you're giving cookies out, you want to give cookies to everybody. I can simplify 10 divided by 5 is 2. 3 divided by 5, excuse me. This is not simplified, so I just keep it negative 3 over 5x. All right, slope-intercept form is check. My slope and y-intercept now, I can identify the slope is negative 3 over 5. So really my rise is negative 3, my run is 5, and then my b value is 2. So I'm going to go ahead and plot the y-intercept, plot 2. And then my rise is negative 3, so from here I go 1, 2, 3 down, and my run is 5. 1, 2, 3, 4, 5. And the idea, these graphs only go up 5 spaces, but if you would do it again, 1, 2, 3 down for your rise, 1, 2, 3, 4, 5, whoops, right about here, then you would get another point, and 1, 2, 3 down, 1, 2, 3, 4, 5. Notice all my points seem to be in a straight line, and they should, okay? Real quick, let's say, and if this confuses you, I apologize. So if it does, just kind of ignore it. But some people say, well, what if you put that negative on the bottom? What if I had put the negative with the 5 instead? Okay, so you had said from the beginning, I'll use a different color to represent it. You had chosen to graph it like this with the negative on the run instead of the rise. So the first thing you do is plot your y-intercept 2. And then your rise was 3, so 1, 2, 3, because it's positive. But now your run is a negative 5, so negative goes in the negative direction of the x's. 1, 2, 3, 4, 5. And again, if I had drawn a straight line, it would have worked, okay? So it doesn't really matter where you put the negative, but like I said, for consistency, just so we keep it going down or up from the first start, I'm going to put it with the y value, the rise. All right, let's try another one. Again, not in slope-intercept form, so I'm going to get it there. Function form, by subtracting 8x, I get negative 3y equals negative 8x plus 2. Then I'm going to divide by negative 3 every term. Y comes down. Negative divided by negative is a positive, so I get positive 8/3 x plus negative 2 over 3. All right, so my slope in this case is 8/3. My y-intercept is negative 2/3, and I'm going to go ahead and graph. So the first thing I'm graphing, excuse me, is my y-intercept. Now I get negative 2/3, which is really a fraction. Your y-intercept you can put as a decimal. That's perfectly fine, because this doesn't involve a rise over run like the slope does. So it's really negative 0.6 repeating. So basically, knowing that I'm going to go down 2/3, it's approximately here. To get it perfect, I could make my increments by thirds, and that way, like, I would go down the approximate correct length, but I'm going to approximate it here to negative 0.6 repeating, or negative 2/3 for my y-intercept. Now I'm going to go up 8. So I have to remember this is up 1, up 2, up 3, up 4, up 5. I'm going to go off the chart. Up 6, up 7, up 8. Okie doke, so it's a little high, but I don't put my point here. I just did it for marking purposes. Now I have to go my run, which is 3. 1, 2, 3. And that's my second point. First point, second point. There's my graph. Nicely done, guys.